All right. Good afternoon. Welcome back. And I'm going to go ahead and just get started into the next set of things. And if you do have any questions, please stop me. Um, as a reminder, if you have not taken, there should be a practice Blackboard test available to you on Blackboard. So make sure you take that because that'll be the closest thing to practicing for your actual Blackboard test. You'll get feedback on it. You can take it again. And if you're still not sure why you're missing something, that's a great question to ask me because I can go in and look at your results on the practice set and give you some feedback if I see something that's wrong, if it's not giving you feedback otherwise. So saying all that, last time we covered some of the conversion factors. We covered some of I think that's all we did last time. And then we covered previously on some of these questions about labels and things like that. I'm realizing that some of my labels didn't copy over, so I'll have to get that the next time. So that's not nice. All right. Anyways, so what I'm going to do next is one of the ones that you'll see that could be a little bit weird, and it's what's called the fluid replacement volume questions. So each campus asks this question just a little bit differently. So on the blueprint, it says that you're going to do what's called a replacement volume or calculate a total volume, an intake. So it's an intake output or an IO problem. What we're doing is a replacement. Basically, we want to know how much the patient voided and how much to replace with. And this is just kind of practicing essentially a ratio sort of situation. And so I have two questions here. They're basically the same question, and we'll go through them. That way you have an idea of how to do this. So you can use dimensional analysis for this. You can use ratio proportion for this. And that's actually what I used when I initially solved this. You can do ordered over available. It's just that everything's in milliliters, so it gets a little bit weird. And so that's why I typically like to just use it doing ratio proportion. And when I say ratio proportion, I just mean like you're just kind of comparing like things. So in this equation, we have a couple things. We have, it says for every 125 milliliters urine output, so that's one thing, you're going to replace with 40 milliliters. Okay. So for every 125, you're replacing with 40. Okay. The next thing is there's some extra information here. What we're replacing with, water, how we're doing it, a PEG tube, how often, every 4 hours. And really what this every 4 hours is telling you is just how often you are kind of reading what the urine output was and then getting feedback and then adding more liquid to them via PEG tube. So if it says if urine output over the last 2 hours or 10 hours or whatever it is, you still would just use whatever numbers you have available to you. But typically these numbers are going to be consistent, meaning if you're checking or replacing every 4 hours, then you're going to be paying attention to the output every 4 hours. So in this instance, it tells you that the output, the actual output was the 500 milliliters. So those are all the key pieces of information. And then we were going to calculate the new replacement volume. So when I'm doing and setting up a problem like this, and I'm following what I call, or not what I call, but what's called ratio proportion, what I'm doing is I'm just setting up equivalents. And what I'm going to do is I'm going to say, and it really doesn't matter how you do this, but let's say this is my output and my replacement volume. So these two are kind of connected to each other. So 125 is my output volume and my replacement volume. That's my given. And then I'm setting that equal to my output, which is actually 500. And we don't know what this is. Okay. Now you can put that, you can put a variable there. You can say X or A or whatever you want to do. That's fine. But this is one way to kind of solve this. And this is where, if you remember back in math class where you had to cross multiply and then divide, that's exactly what you're going to do with this situation. Now, sometimes I write that up and people go nuts and they say, what are you writing here? Don't do that to me. So let's look at another option. Okay, so this is one way that you can solve it. This is called ratio portion. Okay, you can do dimensional analysis. So I'll just write DA. So with DA, it's just a little bit kind of funky, but it still works out similarly. So I want my replacement volume to be the top number. And so what you're doing is you're just making some comparisons while eliminating some things. So let's say my comparison is, or I'm looking for my replacement volume of 4 or 500 milliliter output. What I want is, if my original output was 40, I want to make the comparison where my original ratio was, so this is my replacement. I'm just going to write a little R there, or I'll just put a big R. Oops. And this is my output. And what I'm trying to do is I'm trying to make a comparison where I'm getting rid of my actual output. So remember, the reason that I get stuck on this sometimes, even when I'm trying to explain this, is because everything's a milliliter. So what are you canceling out? Well, that's why I put this little subscript O, because these two cancel out, and then we're left with our milliliters of our replacement volume. So that's how you could do a dimensional analysis. You could have also written this in the reverse order. Okay, so I could have written this as 500 milliliters out times 40 milliliters over 125 milliliters, and I could have gotten, and I'll get to the same answer. The next option, because some of you like to do the ordered over half, so I'll just do O over H. Okay. Now, this is weird because what's ordered? Nothing's ordered, but your 500 milliliters is like your basically what you're looking to get feedback on. And then what you have available, for lack of a better term, is the 125, and then your quantity is the 40. So I'm showing you 3 different ways, and I'm showing you 3 different ways just because I don't care which way you do it. Just make sure you do it the right way that works for you and that you get to the same answer. In one of the note pages I have, I gave like I did basically ordered over available, and I said take the actual output, divide it by the experimental or theoretical or expected output. So in that instance, 500 over 125, and then multiply it by the replacement volume. And if you do that, you'll get it right every single time. Okay, so try number 12. And see if you get this. Let's just see if we can get consistent answers. So if you have access to your chat, just go ahead and try number 12. I'll leave up these formulas up here, and I'll just leave this here. Maybe you can see that. Okay, let me open this up a little bit more. So it's now for this one, it's for every 100 milliliters replaced with 30 every 3 hours, and after 3 hours, 400 milliliters lost. So just see if you can get the same answer I would get without looking at the key, and just type it into the chat when you get it. And if you don't know, just a question mark is fine, or I don't know, that's fine too. Well, and I'm glad that you said that you did it the other way, because that's a common thing. So the way that I kind of chop that up and to try and make it so you don't make that mistake is you got to kind of pay attention to what each of these things are. So this is like your expected output. Okay. That's like kind of like your what you have available quantity wise, even though it's still in milliliters. It's your expected output. And then the next one where it says if urine output for the last 3 hours was or is 400 milliliters, this is your actual output. That's what they actually voided. And then we just, and then this is my replacement, which I usually don't have to explain. And so the way that I try to explain this, and sometimes it's helpful, at least it helps me keep it organized. You're going to take your actual out divided by your expected out, and then multiply it by the replacement volume. And when you do that, you'll get the right number. And the other way to keep this in mind, so let's say you did 100 divided by 400. So 100 divided by 400 times 30 gives you 7.5 milliliters. And if you know that you're going to give him 30 milliliters for every 100 milliliters, then 7.5 doesn't make any sense, right? So it's a way to kind of check yourself, is like, wait a second, does this make sense? No, I must have flipped something around. The challenge is, though, sometimes especially when you're first learning these things, is that you start flipping all sorts of different numbers around. So I would say keep your actual and expected kind of together, treat it like ordered over available, and then always multiply by the replacement volume. That way, at least the replacement volume will be consistent. And then if you flipped it around, you should know right off the top of your head. Now, I will also add that if you have an actual output that's less than the expected output, then you will get a smaller ml. So like, let's say the actual output was 50 milliliters, then you would only give the replacement would just be 15 milliliters if it got to that. But I don't think you'll have to worry about that. All right. So again, any of these, always you want to practice. So let's look at some of these other things here. So I think I need to grab a label here. Give me one moment. Set. Let me copy it. Okay. Okay. So we did this example previously. Oh, there it is. Okay. Sorry, my computer seems to be running slow here. Trying to catch up to where we were. There we go. Okay. So we did this question previously. Couple things to pay attention to. So first of all, one of the things that you need to get comfortable with is knowing what these things mean. Okay. They're not super critical for every question, but sometimes they'll try and trick you. And I think the example between the set and the key that I did in order to try and challenge you, not necessarily to trick you, is because sometimes it'll say how many capsules. And if it tells you how many capsules, that's per dose. If it tells you how many capsules per day, then you want to make sure you calculate and know that BID means that you're giving this twice a day. Okay. So when I do this using dimensional analysis, I just take my order, 500 milligrams, and I multiply it by my available, which is 250 milligrams per tablet or capsule. 500 divided by 250. So my answer would be 2. Now, if you're doing this ordered over available, then you're basically writing the same thing. It's just that there's your order, there's your available, but always remember your quantity. Don't forget to write that, because that'll come in handy, and I'll show you a little bit later where it gets commonly missed and people have missed it on tests, similar questions. So that does say caps, not laps, just in case My C looks like an L there. Paying attention to the label, the different things on the label. Okay. The 100 capsules just means that's the total amount. But what you're paying attention to is the strength and how it's administered. So each capsule contains 250 milligrams, and that's how you read those labels. Let's look at some other examples. All right. Potassium chloride question. This is a good question. So let me pull up the potassium chloride things here. All right. So we don't have a label for this one. We just have a cup that's drawn there. I don't think I needed that big. Maybe it should make it a little bigger. So one of the questions you'll get, even if you get this on Blackboard, the Blackboard test, is they might not tell you to circle the correct amount. They might tell you to drop a marker on the correct amount, so you could still get the same answer. So this tells you that you have that the order, or yeah, it's potassium elixir, and then it says 40 milliequivalents POQID. Now, when sometimes students get hung up on this milliequivalents question, mainly because it is just it's the first time they're seeing it. They don't quite understand like what they're looking at there. But what milliequivalents are is just another unit of measure. So it's like milligrams, it's like micrograms, it's like units. It's just called milliequivalents. It's just that's just what the name of the unit is called. So don't get hung up on that. It's just what it's called. And usually you cancel that out in the available dosage anyways. PO, you should know, is by mouth, and QID. Q means Q, think quarter, so think a fourth. So QID is 4 times a day. Okay. So you're going to give this 4 times a day with juice, and then it tells us that what we have available. And in this instance, it says 20 milliequivalents per 15 ml. Now, this is where, so I'll show you both ways. I'll show you dimensional analysis and ordered over available, because both of these things, you want to pay attention to what you have available. And then, honestly, when most students do this question, they don't miss the question. They miss the marking the cup. So don't forget to do the marking part. All right. So it says we have, my order is 40 milliequivalents. So no matter what we're doing, I always start with the order. Whoops, equivalents. And I'm going to convert milliequivalents to milliliters. It tells me that we're converting to milliliters. And also I can look at my cup. I have tablespoons, I have milliliters, but what's my available in? Milliliters. If it's being taken with juice, probably an indicator that it is a liquid or a suspension of some sort, okay? So I want to get rid of milliequivalents, and I want to convert it to milliliters. And then my available is 20 milliequivalents, 15 ml. So I'm going to multiply across top, divide the bottom, or I'm going to reduce, whatever you prefer, and I'm going to get 30 milliliters. If I'm doing desired over have, order over available, then I'm going to take my order over my available. And then this is what's going to get you in trouble if you don't remember it. Don't forget your quantity, 15. Okay. It's not always 15. It's not always 1. Sometimes it's 2. Sometimes it's 5. Sometimes it's 10. Just make sure you're paying attention to what it is. So that way you don't get that question wrong. The 30 milliliters. And then just circle it on the cup. So I just circled my 30 milliliters. You might have to drop like a point so it'll look like a crosshair on Blackboard. So that's all. All right. This is a good question that gets commonly missed, the dilantin question. So let me pull up the label. Oh, it's huge. Let's see if we can shrink that down a little bit. There we go. All right. So it says you are to administer 250 milligrams of dilantin by mouth. How many teaspoons? So this is a big thing. This is where students will miss this because it's asking for teaspoons, but it's available in milliliters. So that means there's a conversion that needs to happen in order to complete this question. You don't necessarily have to do the conversion right when you're doing the question, but you do need to do it. Now I'm going to show you two ways to do this particular question, or if you have something similar. The traditional way is I'm going to take the same kind of steps. I'm going to start with my order, and then I'm just going to convert it. I don't want milligrams. I want, at least in the beginning, milliliters. So 125 milligrams, 5 milliliters. And then if you like to do that, the traditional dimensional analysis, then you would just kind of keep this going. And you'd say, well, I don't want milliliters, I want teaspoons. So 1 teaspoon is 5 ml. And then you can go through and solve the equation that way. Now, I always say, like, some of these things, like when I created them, I kind of paid attention to what things that I could reduce. So like 5 ml and 5 ml cancel each other out. And then 250 over 125 is just 2. So my answer would be 2 teaspoons. If you're doing this ordered over available, 250 over 125, again, times 5, that'll give you 10 milliliters. Then you still got to convert that to teaspoons. Okay. So you just have to remember to convert that to teaspoons, however you do that. Everyone does this a little bit different. So you might do it the dimensional analysis way. You might just know that, you know, if 1 teaspoon is 5, then 2 teaspoons would be 10. But either way, you get the same thing. The other thing you can do is, if you already know that 5 milliliters is equal to 1 teaspoon, then you could just do that as your conversion. So like, let's go back to ordered over available. 250, 125. And I can just multiply by 1 teaspoon. And it saves me a step because you know that 1 teaspoon is 5 ml. And you get 2 teaspoons. So I've seen this question ask how many teaspoons, how many milliliters. Sometimes it'll say 250 milligrams dilantin BID, and it might say how many teaspoons would they receive in a day, how many teaspoons, you know, would they receive per dose. So just make sure you're reading the question when you get to these questions here. All right, I'm going to jump a couple of these and get into some other types of questions. I want to get to the do the 2x next time. I want to get to the sliding scale question because this is a good one. Okay. Should be another picture here. Pull that up. Give me one moment. So this is typically going to show up as a graph. So it's even here. I just need to include my lines. Let's see if I can get them in there. Let's see what it gives me. Okay. So you have something that kind of looks like this, where you'll have sliding scale, glucose reading, and then you'll have a question that basically just asks you, can you read the sliding scale? Then sometimes it'll ask you to mark on a syringe, but this one's not doing that. Sometimes these are reversed, meaning the glucose reading would be on the left side of the graph, and the insulin sliding scale, insulin dose would be on the right side. So just pay attention to that. I don't know if I accidentally did that or why that got flipped around, but anyways. So it says Your patient's blood glucose level before breakfast is 200. What do you do? So based off of the context of this question, you're just going to look at the different ranges. So if it's less than 160, if it's 160 to 220, 221 to 280, you're just going to follow that range. So 200 is in the 160 to 220 range. So there's no math here. You're just going to give 2 units. Okay. You don't need to convert that to milliliters or anything like that. That's just, they're just asking, what are you going to do? And what you're going to do is you're going to give two units. The other question that's kind of similar to this is you might have to mark a syringe. Now, you might see this more so next semester. So I don't know that you'll see this time around, but you might see it. So I'll at least show it to you. All right, give me 1 second. So this question, I think, is kind of getting phased out. I think they usually just care right now if you can at least choose the correct syringe, but sometimes it pops up, especially on next semester's test. So it's good to see it, just in case you do. So that's why I'm going to go over it. So what this is this is just one of the insulin questions where they're going to ask you to look at some information and then how to draw this up. So before I go through the answers, I want to pull up another thing because it's good to see this. So and this is posted in the OneDrive folder. It's the mixing of insulin question. And I'm going to share this here as well. If I can find it, here we go. All right. So what you have here is this is what they're looking for you to mark when you're marking your syringe. Now, in reality, this is not what happens, okay? Because this is not in a vacuum environment. So the insulin's going to mix when you draw it out. So I'm just letting you know that there is a connection there. It's a little bit misleading because it's like, well, why are we drawing this? It's just how they want you to mark it if they ask you this question. So it tells you in this example, and I got this from one of the textbooks, it says that you have 10 units of regular Humulin R insulin and 30 units of Humulin N insulin. So R is regular and N is NPH. And it says, how would you prepare it? So when you actually do this in a clinical setting, you know that you pull out I guess you pull out the total amount, push out the air, you push the portion of air of the regular into the regular and then draw out what you need. There's a whole premise, but you can't obviously talk through that on a test. What they want you to basically get at is that you're going to draw regular first because it's the clear insulin. And then you're going to draw the cloudy insulin second, which is typically the NPH. And the way they want you to mark it is they want you to put your regular insulin, because it was drawn up first, it's going to be closest to this like plunger part of the syringe. And the Humulin N is going to be closer to the needle part of the syringe. Okay. And so this is basically what they're asking you to do, even though it says like make 2 marks, one at the total, one at the regular. I always make a couple of marks to indicate when we're doing this. That way there's no ambiguity when you're answering this question. So if I'm answering this question to be correct, the first thing I'm going to do is I'm going to state next to where it says solution amount to be drawn up first, I'm going to say 10 units regular first. Okay. 10 units regular first, and make sure it's clear that that's what you're doing. And then the total, you're just going to add them up, right? So 10 plus 40. So it would be 50 units total. The next thing is you want to choose the correct syringe. You're going to choose the syringe that's measured in units. Okay. We're not going to choose this one because it's measured in cc's. So we don't want that syringe. So we want to make sure we choose this one. Then we're going to mark our syringe. Okay, so we want to make a mark at the total, which is at 50. And we want to make a mark at the regular, but the way I would mark that is like this. I would put a mark here, and then I would put another mark here.
Sorry to interrupt. I can only see
Oh, sorry.
that's okay.
I forgot to switch my share. Thank you.
Yeah, thanks.
Is that better?
Yes, thank you.
Okay. Yeah, sorry about that, and thank you.
That's okay.
Yeah, so all I did was I wrote out what I'm putting in, the 10 units regular first, and then the correct total. And then we choose this syringe because it's the only syringe marked in units. We don't use the CC syringe because you don't use that for insulin. Insulin is measured in units. You have unit syringes, and that's how that's done.
And you said this probably won't be on our test, right? This is more of like a next semester one.
Yeah, it used to be on the 110 test when it was a paper test, but since it's been on Blackboard, I think they're just going to ask you to choose and mark the syringe. So
Okay.
this
I
is just
did
a little
do the
extra.
practice one on Blackboard and it didn't have one
Yeah.
like this. It just had like choose the right syringe, but it
Yeah.
didn't say to go beyond just picking the right syringe.
And I think you're right. I don't think that there's going to be I don't think this will be on this, but it's good to
Okay.
at least
Good
see
to
it.
know though, yeah.
Mhm. And it's good practice even just for labeling and marking the syringe and paying attention to the units.
Yeah.
But basically, this is how I'm labeling this if I'm labeling on paper. So I indicate where the humulin N is, and I'm indicate or the NPH and where the regular insulin is, and then where the total is. I hope that this is a question that is like kind of getting phased out just because it's really not math, and you got plenty of opportunity to mark syringes. So I don't know that this is necessarily
Right.
one to worry
Right.
about. So did you come across any on the Blackboard test that you kind of had questions about, or did you felt like it was pretty straightforward?
No, yeah, I actually I did it yesterday and I got all of them right except one. And normally on a test, I would always go back and like make sure I did the math right.
Mm-hmm.
But I was like making dinner, so I was just trying to
Okay.
finish it real quick just to like get a quick practice in. And
Sure.
the one that I'm trying to think that tripped me up. I think it was the tablespoon milliliter one. And that was I think I hit the wrong buttons on my calculator because I had it set up correctly. But I just got the wrong answer. I think I would
Okay.
have caught that had I gone back through, which I normally do. Um, so yeah, but I'm gonna do it again just to make sure that I know what I'm doing.
Okay. No, I mean that's all you can do is just, or I mean, it's a great idea to do is just to go through it again. And if that's all you missed, then it probably was a calculator error. So just
Yeah, because I got like 75 or something and it was 37.5. So I think I just either wrote it down. My kids were running in like while I was trying to finish and stuff. So
okay. No, I
I think that
understand
was
that.
a factor, but other than that, I did okay.
You're trying to do 14 things and
Yeah,
yeah. No, I
right,
understand.
right. And in real life, like I wouldn't be, or at the test, that won't be happening. So
Yeah, be a little bit quieter, less running around, less
yes,
other tasks at hand. So no,
right.
okay, good.
Yeah.
All right. Well, I think the next time I'm scheduled to do this is I think the one more before the actual test. So I think that's next Wednesday.
Yeah, I have it on the
Um,
25th.
yeah. So that's when I'll plan to be. So if you have any questions between now and then, just email me and I'll get those over to you. And I'm still pending posting these on Blackboard, but they will be up today because I have some time to actually get them uploaded here in the next hour or so.
Okay, great. Well, thanks. It's been very helpful.
Okay, good. I'm glad you found it helpful, and you're welcome. And I'll see you next week if you're on.
Okay, yes, I'll be there. Thank you.
You're welcome.
Okay, bye.
Bye.